Here is a review for naming formulas for binary ionic compounds. So remember, ionic is a metal and a nonmetal, which means that you're going to have a positive and negative charge. So here are a few examples. If you have strontium oxide, you have to find the charge of each ion. So you would find the charge of the positive ion and the charge of the negative ion. Strontium is +2. Oxide, if you look on the periodic table of ions, is -2. So if you have a +2 and -2, the goal is to get the positive and negative charges to balance out to 0. So since we take +2 and -2, when you add them up, you already get 0. So your formula would just contain 1 strontium and 1 oxide. So just be SRO. Calcium, again, if you look at the charge, is +2. Chloride is -1. So now, since the charges are not equal, we have to figure out how many of each ion we need for those charges to balance out. So since calcium is +2, chloride is -1, we would need a total of 2 chlorides to make those charges equal and opposite. So our formula would be CaCl2 to show that we need 1 calcium and 2 chlorides. Right, the third example, potassium nitride. Again, you would look at the charges. So potassium is +1. Nitride is over here. It is -3. So to make these charges equal and opposite, we would need 3 potassiums for every 1 nitride. So your formula would be K3N. The last two are transition metals, which means that they have multiple charges. And so to show what charge they have, the name is going to have a Roman numeral in them. So remember, this 4 means that tin has a +4 charge. And then if we look at oxygen, oxide has a -2 charge. So to make these charges equal and opposite, for every 1 tin atom, we are going to need 2 oxide atoms. So the formula would be SnO2. All right, the last one, nickel 2. Again, that 2 means that nickel has a +2 charge. Phosphide has a -3 charge. So 2 and 3 both multiply into 6. So the goal is to end up with a positive charge of +6 and a total negative charge of -6. So to make that happen, we would need 3 nickel atoms, and we would need 2 phosphide ions to give us a +6 and -6 to make those charges balance out.